A pleasant day to everyone. Today we're going to discuss about electricity and magnetism. Let's have first the properties of magnets. So the first one is magnets have the ability to attract materials that are magnetic in nature. So pag pinag-uusapan natin ng magnets, not all of the materials that we have in our environment can be attracted. And in a magnet, meron tayong tinatawag na attractions or the forces of attraction. These forces of attractions are strongest sa poles of our magnet and weakest naman siya at the center part. So pag sinabi nating forces of attraction, these are produced by the magnetic poles that we have, which is the north and the south poles. So when there is what we call the opposite poles of magnets being placed together, so you will notice that there will be an attractions that is happening between them. And talking about the materials that are magnetic in nature, we have here the ferromagnetics, or these are the materials that are strongly magnetic materials like the iron, nickel, and the cobalt. And the opposite of this is the non-magnetic materials like the copper, zinc, and aluminum. So magnetism comes from a spinning of electrons. So always remember, sa electrons, nagmula ang tinatawag nating magnetism. So how do we demagnetize magnet? In our slides, you can see here that by hammering and heating, you are going to demagnetize a magnet. And also, in the laboratories, for face-to-face, you will notice that when you drop a magnet, you can also demagnetize it. In this slide, I will be showing you different types of magnets and the shapes of it. So the first one we have here, the horseshoe magnets, this one, followed by the ring magnets. Thirdly, we have the cylindrical magnets. Fourth is the bar magnets, which are commonly used in the laboratories. Number 5, the button magnets, which are commonly found sa mga ref magnets natin. Number 6, we have the square magnet. And lastly, the arc and the crescent magnets. These are just some of the examples of magnets that we have. Aside from that, we have the properties of magnets wherein para rin siyang charges. So here, ang pinagkaiba lang, instead na charge, we're going to use the poles. So like poles in a magnet repel, while unlike poles attract each other. So I have here an illustration showing it. So as you can see, when you put north and south part of the magnet, you will see an attraction that will be happen on it. And repulsion naman, or hindi sila magdidikit kapag yan ay parehong south or parehong north poles. Another property of a magnet is when you allow it to hang freely, magnets always align in one particular directions. So yung end pole ng magnet natin will always point at the end poles of the Earth, while the S pole of the magnet will always point at the S pole of our planet Earth. But when we are talking about the geographic end pole of the magnet, this always tells us the magnetic S poles. While our geographic S pole naman, this magnetic end pole of our magnet. So as you can see, the geographic north pole is a magnetic south pole in this diagram. Next is we have the magnetic poles. So always remember that magnetic poles always come in pairs. So if you break a magnet in half, still complete magnets with two poles. So good example of this is this magnet. So when you're going to break this one bar magnet into this part, so you're going to produce two magnets wherein you have here the part na kung saan hinati, yun ay nagiging south, and the other part nung isang magnet. As you can see, this will serve as our end pole of the new magnets. Same process here. When you try to break this, you're going to have 1, 2, 3, 4 magnets with north and south poles. So let's talk about magnetic fields in a formula. But before that, let's have first the magnetic flux. So magnetic flux is actually the number of magnetic field lines passing through a given region. So this is the symbol for magnetic flux, and the SI unit is Weber for magnetic flux. So when we are talking about magnetic flux, this is actually 1 Weber is equivalent to 1 Tesla meter squared. Or if we're going to put this into a formula, so since this is Tesla meter, so we can say that Tesla is our magnetic field and meter squared is our area. So therefore, we can say that magnetic flux is equal to your magnetic field times your area. The magnetic field strength of a material or a magnet depends on the number of flux lines that is passing through on it. So pag pinag-usapan natin ang magnetic field strength, this is actually the number of flux line per unit area of a magnetic field. So just like what we have in the previous slide, so magnetic field has a symbol of B and the SI unit is Tesla. So when we are talking about the passing through of magnetic flux line in a certain area, so we have here the unit of measurement. So 1 Tesla is equivalent to 1 Newton per ampere meter. So therefore, based on this unit of measurement, we can say that our magnetic field can be solved using your force over your current value times your length. So that is how you solve for the magnetic field strength. Our magnetic field strength depends on these, what we call the north and the south poles of the magnet. So we have here two scenarios. Scenario A, wherein you can see between the two unlike poles. So what happened to the magnetic field? They are attracted with one another. While when they are in two like poles like north to north or south to south, you will see that there is a great repulsion that is happening on these magnetic fields. And because of this, as we can see on the discussion of magnets a while ago, we have the concept of electromagnetism. So pag sinabi naman natin electromagnetism, this is the relationship between electricity and magnetism. So this was proposed or discovered by Hans Christian Ørsted, that he said that electricity can produce magnetism. So as you can see in his Ørsted experiment, we have here the source, we have the wires, we also have here the loads. So once the source is being open, what will happen to it is that the charge coming from the source will travel through a wires so that it will make the load to functions. And as you can see at the center part of the magnets, we have here the compass needle. So what happened to the compass needle when the electrons passing through a wires? So what happened is these magnetic needles that we have are trying to spin. So that's why we can say that this magnetism can be produced by an electricity. But in an electromagnetism, so electromagnets are magnets that can be switched on and off. So it can be affected by the number of turns in the coils and the size of the iron core. So as you can see, when you try to put a magnet inside the coil of wires, so the induced field inside the coil will try to produce the current which are in opposite directions. While when you try to put out or remove the magnet inside the coil, the current movement will be going inside. So we can say that the current here and the induced magnetic field that we have are in opposite direction. And under electromagnetism, we are using the right hand rule and the left hand rule. So when we are talking about the right hand rule, so your thumb is the one that is pointing where the current is flowing, while your middle finger is pointing the directions of the magnetic field. And while for the left hand rule, we have here the three main functions of our fingers. So your thumb are pointing the directions of the force, while your point finger is the one that is pointing the magnetic field, and your middle finger is the one that is pointing where the directions of the current will go through. So we have here going up, down, inside, outside, left, and right. So current carrying wire produces and enters a magnetic field. So this is based on the left hand and the right hand rules that we have in this presentation. Let's go now with the uses of electromagnetism. Another one, we have here this diagram of an electric motor. So the electric motor is the one that converts electrical energy into a mechanical energy. So as we all know, when we are talking about electrical energy, these are the electrons passing through a wire. So mechanical energy, what are these? So it can be a sound, heat, or a light energy. So it depends on the materials that we are using or the appliances. So that is how electric motor is functioning in this example, use of electromagnetism. Another uses of electromagnetism is through the different measuring devices. So we have here the current meters, which measures the electric current. And aside from the electric meters or the current meters that we also have here the galvanometers, the ammeters, and the voltmeters that are used also to measure the voltage, resistance, and the current of a particular device. So let's talk about the electromagnetic induction. So electromagnetic induction is actually the productions of electricity through a magnet. And because of this, we have the following scientists who contributed on this study. We have Michael Faraday, Joseph Henrich, and Henrik Frederick Lenz. According to them, that here, for the electromagnetic induction, that voltage is always induced, while current can be only induced if the circuit is closed. So pag sinabi natin yung circuit is closed, that it can be that the switch is turned on. So as we can see, or as you all know, when we go back to the circuits, we have here the open and close circuit. So if this is the connection of the circuit, so once that this is not touching each other, so we call this class as an open circuit, wherein there is no flow of electricity. But once that these two touches with each other, so that will now known to be the closed circuit. So kapag closed circuit, dyan na dumadaloy yung mga electrons natin so that the appliances can be working. Here's an example of a GIF showing the electromagnetic inductions by Faraday's law. According to him, when you try to put a magnet inside of this coil of wires, you will notice that the voltmeter is moving to the right side. While when you are going to remove the magnet inside the coil of wires, this voltmeter try to move on the left side of this voltmeter. Another example is using the horseshoe magnets, wherein we're trying to put the coil of wires moving up and going down. So when you move up the coil of wires here in a horseshoe magnet, you will notice that the galvanometer's reading will be going to the left side. While when you try to put inside the coil of wires, so what will happen? The galvanometer's reading will be going to the right side. So because of this magnetic lines of force that we have, we can say that the induced current are in opposite directions also. To sum up everything about electromagnetic induction, so we have here the first one. It occurs when there is motion between the wires and magnetic field. Next, the results are the same when the wires move. when the magnetic field moves or when they are both moved. And third, speed of motion affects the strength of the electric current. Number 4 is the number of loops in the wire affect the strength of the voltage. And the fifth one, any changing magnetic field will induce the current. Where do we use the electromagnetic induction? So we have here the conversion of mechanical energy to electrical energy by the generators. So, opposite siya ng electric motors natin a while ago, wherein yung electric motors natin, it converts electrical energy into a mechanical energy. So another use of electromagnetic induction is through transformers. So transformers, the one changes the voltage and the current. So under transformer, we have two kinds. So meron tayong tinatawag na step-down transformer and step-up transformer. So yung step-up and step-down transformer, nakadepende yan sa tinatawag nating number of turns. So kaya siya tinawag na step-down transformer dahil yung number of turns ng coil of wires, as you can see, from 50, it was decreased into 10 turns. So therefore, mas madaming turns, kailangan mas malaki din yung number ng voltage natin so that we can produce 2,000 watts in a minimal amount of current flowing. Well, kapag naman pinabaan natin yung number of turns, so maliit na lang din yung number of voltage na kailangan with a amount of current so that you can produce is what we call 2,000 watts. So, in the step-up transformer naman, baliktad. So, sa primary natin, lesser yung turns, while sa secondary, mas madami yung turns. And for you to produce 1,000 watts, so as you can see, you're going to increase the voltage from the primary with a lesser turn to 400 volts, while the current is decreasing from 10 amperes to 2.5 amperes, so that you can have the same amount of power in this kind of transformers. So let's try to have some sample problems in electromagnetism. So first, let's have a recall on what is a magnetic field. So when we are talking about magnetic field, this is actually a region in which magnetic forces can be detected, exert force in a magnetic materials. So magnetic field has a symbol of B. So it means that magnitudes refers to the number of flux line per unit area. So that's why when we are talking about magnetic field, you can solve it using your number of flux line over area. Or if you don't have this, what we call the number of flux line, it is the same with your force per your current times the length that we have here. So that's why we have here for the unit of magnetic fields, we have Tesla, which means that is equivalent to your 1 Newton per ampere meter. But when we are talking about magnetic flux naman, so ito yung number ng magnetic field lines natin passing through a given region. So it has a unit of measurement which is a Weber. So here, if we're going to talk about magnetic flux, this is actually your magnetic field times the area. And sometimes we are using also angles here. So you will see that in our sample problems later on. Let's talk about magnetic fields. So for magnetic fields, we have here the formula. Force over QV sine theta. So wherein your force must be in Newton, and your Q is your charge in coulomb, and V is your velocity, which is in meter per second, and your B is your magnetic field intensity, which is in Tesla. So we are using here the sine theta for us to solve for the value of angle. So if the magnetic flux is given and the area, you can use this formula, magnetic flux over area, or kung may angle involved, we have magnetic flux over A cosine theta. So we can still solve for this magnetic field using this formula. Let's try to use the formula that we have into a sample problem. So I have here, calculate the intensity of a magnetic field. It was known that a 38 Newton force is exhibited by a 0.390 coulomb charged body at a speed of 28 meters per second. So the magnetic is tilted at 55 degrees angle. So una, identify natin yung given. So our given, we have here your force, which is 38 newtons. You also have your charge, which is 0.390 coulomb. Your V, we have 28 meters per second. And your angle, which is 55 degrees. So we need to find for our magnetic field. So for the magnetic field, based on our given, we can use, and take note that this Q can also be denoted as small q. So if the formula for the magnetic field, we can use this V is equal to your force over Q V sine theta. Substitute, we have 38 newtons over 0.390 coulomb times 28 meters per second times sine 55 degrees. So your B, or magnetic field, will be 4.25 Tesla. In our previous lesson, we also have the definition of electromagnetism. So it is actually the relationship between electricity and magnetism. So electromagnets are the magnet whose magnetic field is produced by a current passing through a coil of wires wrapped around a core. So the strength of this depends on the number of turns of the coil and the current that it will be producing or using. And with that, with our previous slide, so let's calculate the magnetic force of a current carrying wire on a moving charge. So for the formula, you're going to use F is equal to ILB sine theta, wherein still the same. Your F is your force or the magnetic force, I is your current, which is in ampere. Your L is your length of wire, B is your magnetic field intensity, and your theta is your angle involved. Let's apply the formula into a sample problem. So we have here determine the magnetic force exerted on a 90-meter length of an electric power line carrying a 1,300 ampere in a location where the magnetic field is 4.0 times 10 raised to negative 5 Tesla at an angle of 65 degrees. So here we are going to find or look for the magnetic force. So for our given, we have our length, which is 90 meters, your current, which is 1,300 ampere, your magnetic field, which is 4.0 times 10 raised to negative 5 Tesla, and the angle, which is 65 degrees. So using the formula, F is equal to I LB sine theta. Let's substitute. So we have 90 meters times 1,300 amperes times 4.0 times 10 raised to negative 5 Tesla times sine 65. So you have here for your magnetic force, which is 4.24 newtons. So aside from that, let's have first the two laws describing the electromagnetic induction. So according to Faraday's law, whenever there is a change in magnetic flux in a circuit, an induced current and induced EMF is produced. So the induced EMF is proportional to the rate of change in the magnetic flux. So meaning to say, the voltage is higher, so the flow or the magnetic field is also higher. So in other way around, kung mababa yung voltahe natin, mababa rin yung flow ng magnetic fields natin. Well, for the Lenz law, according to him, to Frederick Lenz, so the induced current flow in a direction so as to oppose the change causing it. So, ito pinag-uusapan dito yung voltage and yung current natin. So, when your voltage is going forward, so the current is opposing in movement. So, the same with kapag yan namang voltage natin is away because of the magnets that we use, So the current is going inside. And here's some of the Lenz law applications. So we use the electromagnetic brakes and induction cooktops. We have the electric generator and the alternating current generators, the metal detectors that commonly used in airports and some malls, the eddy current dynamometers which are using to measure the current, the braking systems on the trains use the Lenz law also, the card readers that we are using in our memory cards, and also in the microphones that we have at home. So for the Lenz law formula, we have this E is equal to negative N, the flux 2 minus Q, or the flux 1 over the change in time, or sometimes your induced EMF or E is equal to negative N multiplied by the flux line or the flux that we have or the magnetic flux over the time. So you can solve it also using this formula. And our magnetic flux can be solved using BA cosine theta, wherein yung B natin, yung magnetic field, which is in Tesla, area, which is in meters squared, and angle, cosine theta. So therefore, we can also say that instead of using this flux formula, we can substitute it using this one, BA cosine theta. So let's try to solve some sample problems related to Lenz law. So in this problem, you can see that a coil of wire is situated at 0.6 Tesla uniform magnetic field. The area of the coil is 3.0 meters squared. What is the magnetic flux if the angle between the magnetic field and the normal to the surface coil is 75 degrees? So after 3 seconds, the magnetic field now is parallel to the surface. So calculate for the induced EMF. So for this problem, we have here the magnetic field, which is 0.6 Tesla, the area, which is 3 meters squared, the angle, which is 75 degrees, and the number of turns, which is 1 turn only, and the change in time, which is 3 seconds. So, una, let's try to solve the magnetic flux. So, using the formula, magnetic flux is equal to BA cosine theta. Substitute, we have 0.6 Tesla times 3 meters squared times cosine 75. So for your magnetic flux, we have 0.46 Weber. So since we already have the magnetic flux, we can now solve for the induced EMF. So for the induced EMF, we are going to use the negative N times the magnetic flux over your change in time. So substitute negative 1 times 0.46 Weber over 3 seconds. So the answer will be 0.15 Weber per second. So that is now our induced EMF. So since this is negative and it is opposing, so we put negative sign on this answer that we are going to have. So that is a sample problem for our Lenz law formula. Just a few reminders at this point. So on Thursday,